Chapter 6, Question 2, is very similar to Chapter 6, Question 1. It's asking you to state the number of electrons, in this case, that must be gained by atoms of each of the following in order to achieve a noble gas electron configuration or arrangement. So to review what that is, I would go back to the exercise for Question 1. It's where an atom has no unpaired valence electrons. And so I'm just going to follow the method that we established in exercise 1 and apply it to each of these in this video. So the first thing we want to do is to draw the Lewis dot symbol for each of these elements. So for the first one, for chlorine, chlorine is over here, sort of in the top right of the periodic table, and it is in group 7A. So when you draw the Lewis dot structure for that, so chlorine, you draw the symbol, and that represents the nucleus with all of the inner electrons. Now we just have to draw the outer electrons. Because it's in group 7A, there are going to be 7 outer or valence electrons. And we're going to put them around chlorine as if chlorine were on a box that had 4 sides. We're going to put 1 on each side before we start pairing them. So we have 7 because it's in group 7A. So 1, 2, 3, 4. Now that I have 1 on each side, I can start pairing them. 5, 6, 7. And so you don't want to keep those lines there. I'm just putting that there as a guide. But this would be the Lewis dot structure for chlorine. You can see that it has only 1 unpaired electron. So to get all of its electrons paired, all it has to do is gain 1 electron. And so they're asking you to state the number of electrons that must be gained. Okay, well, chlorine, in the case of chlorine, 1 electron, the symbol for electron is lowercase e with that sort of negative sign in the top right. 1 electron must be gained. And if 1 electron is gained by chlorine, then it has all paired electrons, just like the noble gases in group 8A. Those are the noble gases on the right side of the periodic table. Okay, so that's chlorine. Let's try Se, selenium. So selenium is over here, sort of at the right side of the periodic table. And so we can draw the Se, the symbol, that represents the nucleus and all of the inner electrons. And because selenium is in group 6A, it's going to have 6 valence electrons. So I'm going to put 1 on each side of selenium before I start pairing them. 1, 2, 3, 4. Now that I have 1 on each side, I can start pairing them. 5, 6. So you could see that to have all paired electrons, selenium would have to gain 2. Gain 2 electrons. So in the case of selenium, 2 electrons must be gained in order for it to have all of its electrons paired like the noble gases. In other words, in order to have a noble gas electron arrangement. Okay, let's try nitrogen. So nitrogen is in the top right of the periodic table. So to draw the Lewis symbol for that, you draw the N, and then because nitrogen, and that symbol, that N, capital N, represents the nucleus and all the inner electrons, because nitrogen is in group 5A, it has 5 valence electrons. I'm going to put 1 on each side before I start pairing them. So now I have 1 on each side, so I can start pairing them, and there's 5 electrons. In order to have all paired electrons, I just need to add 1, 2, 3. So 3 electrons must be gained by nitrogen in order for it to have all paired electrons like the noble gases. In other words, in order for it to have a noble gas electron arrangement. Okay, let's do a similar thing for iodine. Iodine is in the bottom right of the periodic table. So when we draw its Lewis dot symbol, we can draw that capital I, that represents the nucleus and all the inner electrons. So we just have to draw the outer ones, the valence ones. Because iodine is in group 7A, it will have 7 valence electrons. I'm going to put 1 on each side before I start pairing them. So 1, 2, 3, 4. Now that I have 1 on each side, I can start pairing them. 5, 6, 7. You can see that iodine only has 1 unpaired electron. So in order to get all of its electrons paired, for it to be stable, it would just have to gain 1 electron. So 1 electron must be gained by iodine in order for it to be as stable as a noble gas, because all of its electrons are paired. Notice that scenario, 1 electron, was the same as for chlorine. And so things in the same column tend to need the same number of electrons, either to be gained or lost, and so they tend to have similar properties, things in the same column. Okay, sulfur, that's E, capital S. Sulfur is right underneath oxygen on the periodic table, sort of in the top right. So we can, when we're drawing the Lewis dot symbol, we can draw that capital S, and that represents the nucleus and all of the inner electrons. So we just have to fill in the outer or valence electrons. Because sulfur is in group 6A, it's going to have 6 valence electrons. You're going to put 1 electron on each side before you start pairing them, so that's 4. Now that 1 is on each side, 5 and 6, you can see sulfur has 2 unpaired electrons. So, in order to have all its electrons paired, it has to gain 2 electrons. So in the case of sulfur, 2 electrons must be gained. And so that would be the number of electrons that would have to be gained for question 6, chapter 6, question 2.